Let's get started. In this video, we are going to learn about how to balance redox reaction using ion electron method. So this is an example of a redox reaction. Permanganate under acidic condition can be reduced to +2 oxidation state. So chloride ion is the reductant here, which is oxidized to Cl2. But this equation is not balanced. We are going to balance it. What is the most challenging part in balancing the redox reaction? We are not only interested in balancing the atoms. We are supposed to balance the number of electrons as well. Let's do that. The first step is the calculation of the oxidation state. That is so straightforward. So manganese is in +7 oxidation state. Chloride is in -1 oxidation state. Manganese here is in +2 oxidation state. Chlorine, which is 0 oxidation state. So the second step is calculation of the N factor. N factor is basically number of electrons gained or lost. So for mm per magnet, we're going to calculate the N factor. This is the formula: change in oxidation state multiplied by subscript. So here the change in the oxidation state is +5 because it goes from +7 to +2. Change in the oxidation state is +5 and the subscript is 1. So the N factor here is 5. For chloride, change in the oxidation state is -1 to 0, which is again 1, and subscript is 1. So the N factor for chloride is 1. The next step is cross multiplication of the N factor. We have to multiply the permanganate by the N factor of chloride and chloride by the N factor of permanganate. So which is 1 here, which is 5 here, and also we have to balance the number of atoms on both sides. So manganese, we have 1 manganese here, we have 1 manganese here. Since we added 5 chloride, we're going to balance this to 5/2 chlorine. This is the most important step because the equation is not balanced here. So the next step is balancing the charge on both sides, which is very important for a redox reaction. So the total charge on this side will be -1, -5, -6, +1. So total charge on this side is -5. The total charge on this side is +2, which is not balanced. So we have to do something so that it is balanced. So how can we increase the charge from -5 to +2? We cannot disturb this number, we cannot disturb this number. However, we can disturb this one. So we already have 1 H plus. If I add 7 more H plus, then I'll get +2 here. So by adding 7 H plus to this equation, the total charge on both sides are balanced. So the final step is, so once you add, we have to balance the hydrogen on the other side as well. See, now we have a completely balanced chemical equation, right? So we have 8H plus, which means just add 4 over here, so we get complete balanced chemical equation. Thank you.